So thanks everyone for joining. And based on which location are you at, could be good morning, good afternoon, good evening for you all. So yeah, thanks for joining, and we'll just start. So what's Navan.ai? And like Miriam already explained in one line, in one line, it's a no-code platform for developers and businesses where they can build computer vision AI models. So currently it's limited to computer vision AI models and deploy the models in just a few clicks. Usually any AI model or any computer vision model, if you wanted to build, it would have taken you probably about anywhere between 1 to 3 weeks for a good production ready model. But when you use Navan.ai, we are able to reduce that time by say about 80-85%, and at the same time we make the process very easy. It just takes a few clicks to build the model and deploy the model. So that's where we want to help developers. We want everyone to be able to access and use AI. That's what our mission is. So I'll just introduce everyone who's going to be speaking today. So we have three people from our AI team who will be presenting at different times maybe. So we have Ayush today. So Ayush is leading our AI/ML team. Then we have Ashwin, who is our machine learning engineer, and we have Karthik from the AI team, who is more on the AI side. He's a data scientist. So that's introduction for our team members, and just a little more about what we are planning to do. So right now we have the platform where you can build computer vision models, but what we are currently building, and it's in the process in the pipeline, is that we are trying to build an entire pipeline where if you are an AI developer, you can submit your or you can share your AI model with us, and we'll host it, we'll deploy it, and we'll directly give you an API. So you don't have to worry about deployment at all. You just build the AI model because that's what your expertise is, and you share that with us. You don't have to worry about deployment. You don't have to worry about renting a GPU as well, because that's a significant cost. So you pay as you go, and that's another service that we are working on. And on the generative AI side, because now that everyone is talking about generative AI, it's like everyone has started using generative AI. What we're also doing is we're trying to work on a few models which will be able to generate synthetic data, because data is one of the biggest problems that everyone is facing. So that's something that will be able to offer in a short period of time. When I say short period, I mean like a couple of months, most likely. So that's what's in the pipeline, and I just wanted to share this information. Um, yeah, and just share, like, let you guys know what we're doing and give a brief introduction. So that's all I had to speak about, and I'll invite Ashwin to continue from here. So Ashwin, yeah, please go ahead.
Yeah, thanks. Let me share my screen. Are you able to see the presentation?
Yes.
Yes.
Okay. So, hello everyone. I'm Ashwin. So, I work in Navan, IIT. So, let me start off with a brief introduction on one of our products. We have a image classification model based on EfficientNet version 2. So, this is a brief intro why we chose EfficientNet. So, EfficientNets basically have uh, improved accuracy at the lower parameters. So compared to other CNN models available, EfficientNets are able to reach similar or almost higher accuracies for minimum number of parameters. So this leads us to train and infer using the model more efficiently, and the time taken is less. So that's one of the reasons why we choose EfficientNet. And EfficientNet, it implies a compute compound scaling method for a different versions. So EfficientNet version 2 has like 8 models, scaled up models. So we have the base version B0, and then 1 to 7 are scaled up models. So each can be used for a different situation based on the use cases. So here I've just shown a simple explanation of how the scaling works. So efficient uses compound scaling, which is a combination of depth, width, and resolution scaling. Yeah. So another thing I wanted to share is the default configuration we have for training. So currently we have a set value for the parameters, training parameters, batch size of 32, learning rate, as I've shown here. So in future, we'll be introducing a feature which enables user to configure the training parameters according to the use cases. So till then, this will be the training parameters we'll be using in our Navan AI. So we have 50 box optimize atom function, loss function is category, cross entropy, matrix is accuracy. Yeah, so currently we are able to provide five of the efficient version 2 models templates, and some of the image size recommendations, and the columns in green is the test case which we have done. So based on the data set, how long it will take in our system to train a model of this size. So brief example is, so if you have a simple classification case, like classify between cats and dogs, or from fruits, apples or oranges, that's a simple case. It's not very complex. So in that case, we can use a B0 base model, and the training, it will be done quicker. It uses a less number of layers. It's not much complex. But if we are going to increase the complexity of the problem, like different breeds of a dog, or in industries to figure out the defects in PCP or other such use cases, complexity increases. The number of features the image request will also increase. So in that case, we'll go to higher models, right? Either efficient at version 2S or medium or large, depending on the use cases. So those the remaining three models, the efficient at version 2, medium, large, and Excel models are currently under development. Those will also be introduced in coming next versions. Yeah. Okay. So with that, I'll just go through the Navan AI website and show you how we can train our models. So this is the model page. So currently I have a few models I have tested and worked with. For new users, if you want to create a new model, you can just go to and click the new model button. It will give you the options, whichever is currently supported. So here you can choose whichever model you want. So for example, I'll just choose B0. So once you have created a model, it will create a blank model with the default values. So you can name your model like classification, something, whatever you need. You can add the classes, which classes we want, like 3 fingers or 4 fingers. So I have an example case here, so I'm showing you that. So I have created a model and defined the classes. Now I can add the data sets here. So the minimum requirement we have set is 20. So by default, we require at least a minimum of something strong on my side. Once again, let me. Okay. So yeah, I added a lot of images, so it crashed my internet. this is the basic step. So you can try to add as many images as you want for each classes. We require at least a minimum of 20 images. Yeah, so once you have the images ready, you can just click on start training. Your training will start, and then you will receive an email notifying you once the training is done. So like I showed in the graphic, depending on the model and the data set, the time taken will be. For simple models, you'll get in a few minutes. If it's a larger model with a higher number of data sets, the training time may take long, but you'll for sure get a notification mentioning the model name. It has been trained and a link to test the model along with this. I'll show the test case with one of the pre-trained models I have. I have a mass detection model. This one already trained. So after I get the email, I can directly click the link and go to this test page. So it will redirect you here. So once you have done training, you can check the model performance using this test page. So I'll start testing. So once you click test, we'll load the model in the backend, and then you can start testing by choosing an images. So this mask detection, these mask data set. So you can test with the test data set you have. You can choose and check how the model is performing. So you get a probability percentage for each class, and yeah, you can test with few other images also and check if your model is performing accurately or not. So this is the test step. So once you are done and confident your model is working fine, you can move to the next step, which is export. Or if you think you can improve the model accuracy a little bit more, you can always add more data sets and create a new version, train again, and test that model, improve on the previous model. So that's the test step. An export option, this is the third one. So here we provide the user with three options. You can either download a model file, download a Docker image which has the prediction code in it. You can start that and run a local service from there, or deploy model as an API. So that the third option, we deploy the model on a server maintained by us. So you don't have to do anything. You'll get an API endpoint which you can call from your system. So yeah, once again. Right. Before that, maybe I can show some other models also, which have industrial use case model. So this one, it checks for damage size in a container. So I have 4 classes defined here: damage top, damage side, undamaged top. Like that, 4 classes are here. So I can test and show you how the model is performing for this. So here I have created 2-3 versions, try to improve the accuracy of. Model is 51% confident it's intact now. One use case. Another one I frequently use for testing is the aggregate data set and gesture classification data set. So here I have 2 examples, best and poor. So I've defined the data set. So the first version itself had given me quite a good accuracy. So I haven't trained it model beyond that one. So the testing, it takes a second to load the model. So once it's loaded, you can test the accuracy of the model. So I can say it's quite uh, accurate in doing the prediction. So I'll go to the next option, export model. So export model, like I mentioned, we have three options. The first one is the download model file. So this one will directly give you the model file. You click on download, and yeah, you'll get a model file and a class name file. So this one I have already downloaded. I have the model file and a class file here. So this I can run it, load the model in my development and use a prediction from it. We have a sample GitHub code to use this one. So yeah, we have a prediction sample code. So I'll explain what we did, what we are doing here. So basically what we do is we get the argument where the model file is, where the class file is. The image path is the path to the image file which we want to predict. So I'm passing those three as in. So it basically what it does is it loads the model, process the image and do an inference and get the inference on it. So that's what's happening here. So we are using Kira's model, Kira's load function to load the model. Then we are processing the image, converting the image to array, normalizing it, then passing it to the predict function. So this will give us the output probability score for each class 0 and class 1, how much percentage it is. So from this, I'm just reading the class names. So that file has just the name of the classes. So this just as a name of the classes in a file. So we can use that and to give the prediction response, something like this. So I can, yeah, so I have already downloaded the model. So this is the, so once you have the requirements installed in your system, you can just run this prediction.py file. So it needs, like I mentioned, it needs three input parameters: so model path, the class file path. So those are just the download directory paths and the path to the image file. So I have an image file attached here. So from one of the aggregate data sets. So it will load the model, do a prediction on it and return the response. One second, yeah. So you, instead of the default output like 0, how many percentage, 1, how many percentage. So I've written a simple derivative of it, which will give us the actual class name and the probability score. So that's one of the examples where you can use this or some other method in your production and use the model directly. Second option is download Docker image. So what we have here is, in addition to the model file, you get a Docker image tar file. So we call it base image here. So I have already downloaded that one also. So once you have downloaded it, you can load the Docker in your either in your system where we want to deploy this in a edge device or a VM. You can just download this one there and load it. So once we have the Docker, we don't need to install or set up anything. We just need to pass the parameters where the model is. Once you give them that, you can just run this command, the Docker path and the parameters. So this will mount the download directory to this container. So from that, it will get the model files and the port number. In this Docker, in addition to the prediction code, we have a fast API service which will be running. So once you start the container, you have a local endpoint available. So there you can just upload the images and get a prediction response, just like the one I showed here. You can get this as a response of an API. Yeah, that's the Docker download Docker part. So these two require some knowledge from the users. So once you have a model file, what to do with it. Some basic knowledge on how to work with the model is required for these two cases. So the third one, it's fully automated. There's no requirement from the user. They can directly call the API and get the response from there. So the third option, the deploy model as an API, we give you the option to deploy the model. So once that's deployed, you'll get a endpoint example and a token like this. So the token, it's unique for each model you have deployed. So for example, if I have version 1 model, test 3 model, I'd have a token for it. If I have a different model like test 4 or test 5, I have a different token for it. So I can basically just use a postman, or in this example, I'm showing you the postman. So I have the token copied already here. So I can send this, and this will call the inference server which we are running. So and we'll get the prediction result quickly. So yeah. Right. So yeah. In addition to that, so this is just a simple Python script on how to call the. Sorry. Once again, I'll show the codes also. My model, yeah, you get a call, so you can use this to call the endpoints. So we have a documentation also. So this will give you, we are using fast API for this one also. So you can get the schema, what are the requirements here. You can try it out and check for yourself. And this is the output of the API. So it will give you the prediction which class is the correct one, and also the probability score for each class for your reference. Yeah, so these two are simple scripts to call the API. So I have written a Python code which uses requests library to call the API. There's also a JavaScript to call it example. So like I mentioned before, the user's side work is minimum. So there is no automation work. There's no deployment work. So the users can directly call this API and infer from it. Yeah, so these are the three deployment options currently available. Just go through the slides once, and yeah, we have three options like I mentioned. The first one, like I said, you just click the download button, you get the model file. You can use the GitHub repo link in our website. Also, there is a link there. You can use that same code in your development, or refer to that and create a code, inference code from that on your own. Second option is the Docker image. So this one, like I mentioned before, it has all the prerequisite libraries installed and a fast API service, which you can start by running the container. So once you start the container, the fast API service will be running in the local system or in the edge VM or devices where you have started the container. So with that, you can directly call the service and the info from it. And the third option, like I mentioned, is the deployment as an API option. So yeah, this is the one with the minimum work requirement to help the developers reduce the workload, to take up all the deployment and automation tasks on our end, so the users can freely work on their production codes without worrying about the GPU cost and everything. So yeah, we are using GPU accelerated VM, so inferences can be fast and everything. efficient. We have automated the pipeline for deployment, so it's just one click away. You just click download a deploy model and it will be deployed, and you can start using the API with the token. It's easy to integrate, like I showed you. We can deploy and use the API in Python or JavaScript. You just need to call the API. And yeah, so specialized knowledge on deployment is not required. The users can focus on how to use the result in their own production. So some of the use cases is we can have a app for a children educational app to classify animals or plants, which can make use of this API instead of running this code on the local system. We can have a production classification in industries to manage inventories, or one of the use cases like you mentioned, to see the faults in the products. Another one is a mobile app, like the educational app similar to that. We can make use of the API instead of running it in local system. Yeah, that's a brief demo of this product. So you have any questions?
Ashwin, I just have one suggestion. Would it be possible for you to show an inference using the API?
Okay. Yeah. So this is the token I used for one of the models. We share. Okay. So this is a S10-4, right? So yeah, I've already deployed this in our endpoint server, so I can just copy the endpoint. So we need to pass a file as a. So once again, yeah. So it's as fast as that. We can get the response within 1,000 millisecond. Prediction score and the predicted class. Those things will be given in the response. So it's as easy as that.
Ashwin, are you sharing your response? We can't see the response screen.
Oh, okay. Sorry.
That must be in a different script window, maybe.
Yeah. Sorry. Are you able to see it now?
Yes, yeah.
Right. So I'm not able to switch screens. It's not able to share this. So I have copied the token from here and pasted it in this Postman application here. It's one of the parameters. So the token is here, and whichever image I want to influence also I've added here. I'll go through it again. Just a test data. So once I click send, yeah, it takes a few milliseconds to get the response. The image I shared is a person showing 4 fingers, so it's predicted accurately. The probability score for 4 is 89%, test is 10%. So yeah, predicted class 4. Get a response like this.
All right. Anything else, Ashwin? We're done, right?
Yeah, I'm done. You can ask.
Okay.
Anyone
Yeah.
has
So,
question?
yeah, we are open for questions, discussion, suggestions.